Students, we are doing questions from Concepts of Physics by HCVERMA Volume 1, Chapter 3, Rest and Motion, Kinematics. Here we are doing exercise. Question number 20. Complete the following table. Here it is mentioned that there is a car model is given. Then this is A model and it has a deceleration 6 meter per second square. This is B model having deceleration 7.5 meter per second square. There is driver X whose reaction time is 0.2 seconds and there is driver Y whose reaction time is 0.3 seconds. The speed of the driver X initial speed is 54 km per hour in model A, and in model B initial speed same speed 54 km per hour. We have to fill in this. What is the braking distance? What is the total stopping distance? What is the braking distance here? What is the total stopping distance? And all this. Students, we have to understand that during the reaction time, I am writing it down here. During reaction time, the speed of the body, the speed of the vehicle does not change. So the distance covered during the reaction time is in the first of all I am taking the case here, students, in this case. So in this situation, let us say this is X WZ. These are the 7 cases which I am taking, 4 cases which I am taking. X, the distance covered during the reaction time will be, it is mentioned this, the initial speed is 54 km per hour. U is 54 km per hour, which I can write as 54 into 5 by 18, that is 15 meter per seconds. Now initial velocity is 15 meter per seconds and during the reaction time of 0.2 seconds, S during reaction time will be 0.2 into 15, that is 3 meters. Now the brake deceleration is 6 meter per second square and final velocity is 0. Therefore, I can say that I can apply v square minus u square is equal to 2as to find the distance traveled during the braking time or the braking distance. That is v square 0 square minus u square 15 square is equal to 2 into acceleration or deceleration is minus 6 into s. So I have, students, this is minus 225, that is equal to minus 12 into s, that is S is equal to 225 divided by 12, that is 12 ones are 12. Then I have 10 balance remaining, 105, 105, 12, 8, 96, and I have the balance of 90, 12 7s are 84, 60 balance, 12 5s are 60, 18.75. This is the braking distance, students. So total distance, total stopping distance. So here the braking distance I can put it as A as 18.75 meters. Total stopping distance is the reaction time distance plus braking distance, that is 21.75 meters, students. And now with the other situation, let us see what happens. Now that there is driver Y, the reaction time was 0.3 seconds and initial speed is 72 km per hour. So let us write down for that. That is the situation Y I am writing down. Y. So initial speed is 72 km per hour, or that is 72 into 5 by 18, that is 20 meter per seconds, and the braking to find out the reaction distance covered during the reaction time. His reaction time is 0.3 seconds, students. Therefore, 20 into 0.3, that is 6 meters. So, because he has a larger reaction time, there is a larger distance, and its initial speed is also large, 20 meters per second. So, now we have to find out the braking distance. Initial velocity is this, final velocity is 0, and his acceleration or deceleration is given to be 6 meter per second square. Now, students, with these ideas, I will apply v square minus u square is equal to 2as. I have 0 square minus 20 square is equal to 2 into 6 into s. This is negative value because it is deceleration, and therefore as I have 400 divided by 12. With this idea, I have a value 12, 336, and 40 remaining, 12, 36, 33.33 meters, like that. And the filling, what we have to fill will be, the braking distance is 33.33 meters, and the total stopping distance will be 39.33 meters. We have filled the first row now. Now we go to the second row, and the first one we have to take is these W, left hand one. For W, the initial speed is 54 km per hour. That is 54 into 5 by 18, that is 15 meter per second. The reaction time of the driver, the first driver is, you already know it is, the reaction time of the first driver is 0.2 seconds. So I can say that T reaction, that is equal to 0.2 seconds. So, and reaction distance SR, that is equal to 15 into 0.2, that is 3 meters. Now we have to find out the braking distance. For braking distance, I know that final velocity is 0, and I have final velocity 0, and I will apply v square minus u square is equal to 2as. 0 square minus 15 square is equal to 2 into the deceleration of the car B is minus 7.5. A is minus 7.5 meter per second square into s. So I have, students, in this way, s is equal to 15 square, 15 into 15 divided by 2 into 7.5. Negative sign got cancelled from both sides. This 7.5 into 2 is 15, and this 15 cancels, therefore this distance is 15 meters. This is the distance, braking distance. Now coming back to our data filling, let us go back to fill our data. The braking distance is 15 meters. So I'll fill here 15 meters, and the reaction distance is 3 meters. Therefore, this total becomes 18 meters. 15 meters, 18 meters. Now the driver, the other driver Y, with a speed of 72 km per hour. Let us write down that data. Z Z. For Z, the initial velocity is given to be 72 km per hour. 72 km per hour is 72 into 5 by 18. That is 20 meter per second. The reaction time of this particular TR for this particular driver is 0.3 seconds, and as we already mentioned to you, there is no change during the reaction time in speed. Therefore, the reaction distance is equal to 20 into 0.3, that is 6 meters. Now coming to the initial speed u, that is 20 meter per second, braking final speed is 0, and I have its acceleration of this particular vehicle is 7.5 meter per second square. So I am applying this in the equation v square minus u square is equal to 2as, and I get v square 0 square minus u square 20 square is equal to 2 into, this is basically negative number, students. This is 2 into minus 7.5 into s. So s is equal to minus, now we don't have to, the negative is cancelled from both sides, and I have 400 divided by 15. So we have 400 divided by 15, that is 15 2s are 30, and then there is a 10, 15 6 are 90, and then there is a 10, 26.66 meters. So when we fill the data corresponding to this, that is 26.66 distance in meters is the braking distance, and total stopping distance is 26.66 plus the reaction distance, that is 32.66 meters. I hope things are clear to you, students.